Another day, another radio, and today I'm looking at this little thing, little tiny Colt 295. Cute little thing, very cute, but it's also giving me a few headaches, as all these radios do. Trying to get my head around the instructions, which I think are in Chinese. Looking for test points and adjustment points that don't exist. But I shall get there. If we can get past this frog in my throat. One of the mysteries for this little radio is that there's a switch on the front here, and it's labelled RF gain, high and low. And that's exactly what it is, RF gain, high and low. But I was expecting high power and low power, because it's the usual CB2781 type set, which I've been doing quite a lot with. And normally, with the rules and regulations, they all had a switch on them, 4 watts and 0.4 of a watt. That was a crazy rule. If your area was longer than 1.5 meters or over a certain height, you had to run 0.4 of a watt. How ridiculous was that? But that was the rules at the time, just trying to cripple us. Anyway, this set, it hasn't got high power, low power, it's only got one setting, 4 watts. And I will go through the settings a little bit, see what we can do. The first thing that the Chinese instructions say is what? VCO alignment, set the radio to channel 40. Okay, we're on channel 40. And in the transmit mode, okay, we can do that. Make sure you've got a dummy load, yes, we have. Connect a circuit tester between test point and ground. Now, the test point is very hard to find on this, because it's not where I thought it was. However, I need better glasses. Put it there on test point on channel 40, and adjust L116 between 2.5 volts. So there we are, transmit 2.6. We're wiping out the other radio which is in the room. Better switch that off. 2.6. So that's pretty close. I don't believe in adjusting things for the sake of it. So that's pretty much where it should be. Then just set the radio to channel 1 and in receive mode. Wrong way. Channel 1 and in receive mode. Check to see that the voltage is dropping to 2 volts. Okay, let's find it again. Well, in this case it's dropping to 1.7. Right. As long as the DC level between stays 2.5 and 2 volts, as long as the level stays between 2.5 for transmit at channel 40 and 2 volts to 4 volts for receive at channel. 2 to 4 DC for receive at channel. So, receive 2 to 4. 1.8. There's your 4. Channel 40 is 4. Channel 1 just under 2, it's 1.7. But we can do no more really. There's not much you can adjust on these. We could try and do it, but since it's right, it's 4 volts on the one channel, it would upset that setting. So I don't believe in disturbing things too much unless it's really necessary. So that's the VCO. The next thing we're going to do is the transmitter side of things, and it says select channel 20. 20, and it gives me a whole string of adjustments here now to do on transmit. Connection oscilloscope, adjust adjust this, that and the other, load of adjustments for maximum, then the power amplifier stage, adjust this and this for 4 watts output. So we've got all these things to adjust for 4 watts output. However, this is referring to set straight off the assembly line. Well, let's see what the output is. If the output is 4 watts, there's no point in twiddling that lot, is there? So let us see, before we go mad and start twiddling everything, if the output is 4 watts, and if it is, we shall leave it alone. Let's move the camera around and point it at the power meter, and we'll check what the power is. Right, let's see what the transmit power is. It's not entirely straightforward just pointing the camera at my power meter here. I get reflections off the lights, so I've got to find a happy medium. Let's connect things up. Let's connect this lead up here. Connect that to the frequency counter, then we can kill 2 birds with 1 stone, you see. We're on channel 20, transmit, there we are, 4 watts, near enough, just a fraction under 4 watts. And the frequency, 277909, so that's well within spec as well. It should be 2791, but it's 0.9, so it's close enough, it's well within the spec. So again, why twiddle it? Why mess about? Nothing wrong with that. Frequency just a fraction under 4 watts. Sorry, frequency just, power just a fraction under 4 watts. And frequency pretty much within a couple of hundred cycles of where it should be. So to start disturbing the settings just for the sake of a couple of hundred cycles, there's absolutely no point. It's good. It's pretty much as it should be, well within spec, and leave well alone. So frequency is okay, power is okay. The next thing to check then is the deviation. See if the deviation is within a reasonable setting and not been messed about with. So we'll switch the deviation meter on and point the camera in that direction. Let's see what the deviation is like on channel 20 then. As usual, I've got the deviation meter set on the 0 to 3 kHz scale, which is the clearest one to use. So we should be around about 3/4 scale. Key up. Meter goes to the left. 1, 2, 3, 4, 5. They are 2.2, 2.3 peak. So perfect, absolutely perfect. Can't fault that. So the deviation is 100%. The power is right. The frequency is right. The only thing left to check then is to see how sensitive this little set is, how it stands up to sensitivity in comparison with other sets. So let's set it up now for receive and check the performance that way. I'm back again. I didn't have time yesterday to finish the test on this little radio because I wanted to give a thorough check on a fault which it had. I'll mention it in a moment. Anyway, there we are. I'll just move a little bit so we can see what's going on. There's the cyanide. There's a cyanide measurement. 20 dBs. 12 dB cyanide, and signal generator -120. So -120 sensitivity. What more can you say? turn this noise down a little bit. So here is the completed Colt 295, all finished, back in its case, doing everything it should. I adjusted the frequency a little bit more to make it closer. It was within 200 Hertz, but I gave it another twiddle and put it exactly on frequency. So that's it, all up and running. But it had an interesting little fault which I'm going to discuss now. Let's just turn this off. Turn it off and disconnect the aerial. And I want to discuss this fault because it was an intriguing little fault. When it came, the first thing that was wrong with it was it had the power connected the wrong way round, as happens with these radios many times. But it had not done any damage whatsoever. We've been lucky. It had just blown the protection diode, and it must have had the right fuse in it at the time, so nothing was done. It was just a case of replacing the protection diode, and it was perfect. Couldn't fault it. However, it had an intermittent transmit. Sometimes when you keyed up you got 4 watts, sometimes you didn't. And I had the same fault on receive with the signal generator. On receive it was intermittent, which was very strange. And what it turned out, the little socket on the back, when you tighten it up, it was moving slightly, which wasn't good. Now, when this was assembled in wherever it was it made in Korea, they put a big nut on the back of this. Screw this in when they assembled the chassis in the first place, put a big nut on it to hold it tight, and then they put about 100 weight of solder on the nut so it's not going to unscrew anymore, so it holds it firm. However, over the years, tightening aerials in and out, it had gone a little bit loose. I mean, it wasn't tremendously loose, but it was moving, so when you tighten the aerial up it would move maybe about 1/8 of an inch and then move 1/8 of an inch back. So it was a little bit loose, slightly, and that looseness had caused corrosion around the socket. So amazingly it was affecting the transmit and receive because the outer of this connector wasn't making a good connection to the chassis, and that was the fault. But of course it was a bit of a problem to sort out, because the ideal thing would have been to take the connector off, clean it all up and put it back. But you couldn't put it back, you couldn't take it off and put it back because of the 100 weight of solder. So what I did, I used good old Aldite, put some Aldite on the inside to stop it moving so it would no longer swivel backwards and forwards. And then to solve the slight poor connection, I then soldered a copper strap from the inside of this to a ground point. So once again it had 100% good ground. And that was it. But it was just a tricky little thing that it was intermittent. Intermittent faults are always the hardest. And it was just down to a slightly loose connection, which I wouldn't have thought had been a problem, but it had corroded inside the nut and inside the connection. And so that was it. Anyway, all working spot on. Can't fault it now.